Hello students. So again we are going to start power measurement in three-phase AC circuits. So for power measurement there will be three methods. One will be 3 watt meter method, second is 2 watt meter method, and third is 1 watt meter method. The most popular and useful method is 2 watt meter method, but we will discuss each and every method simultaneously one by one. Okay, so first of all let us discuss what is wattmeter and how we can measure the power using wattmeter. So basically wattmeter is a device which have a current coil and a potential coil. This current coil this is your current coil and this is your potential coil. This current coil is connected in series with the circuit and this potential coil is connected in the parallel. So it will measure the voltage and it will measure the current flowing in the line. So basically wattmeter is a device which have two coils. One is current coil and second one is potential coil. This current coil is connected in series and potential coil is connected in parallel. So here this is a connection diagram. We are having a three-phase star connected circuit, and look here, this is your current coil of wattmeter W1 and this is your potential coil. So here potential coil is connected between this phase and neutral point. So what voltage it will measure? It will measure the phase voltage. Clear? Because it is connected between these 2 points here and here. So between a phase and a neutral, between line and neutral, so it will measure the phase voltage. So it will measure VRN, and what the current is flowing through this current coil, this current IR is flowing through this current coil. So it will measure the current in R phase and voltage across this R phase. Similarly for this W2, what current it will measure? It will measure the current IY, and what voltage it will measure? It will measure the voltage VYN. Clear? Now for here, this current IB is flowing through this current coil of W3 wattmeter, and what voltage it will measure? VBN, the phase voltage between phase B and neutral. So overall the total power will be equal to what? Sum of all these three wattmeter readings, W1 plus W2 plus W3. You will get the total three phase power, because what you are doing, current into phase voltage, current into phase voltage, current into phase voltage. So you will get three phase power, 3 VPH IPH cos phi. Clear? So this was your 3 wattmeter method. 3 wattmeter method. Now what we will start? We will go with 2 wattmeter method. The main important concept that we have to learn. 2 wattmeter method. What we will do, we will connect the wattmeter in any of two branches, and we will make one branch as common. Here this will be your circuit diagram. This Y branch is made as common branch. So what voltage it will measure? VRY, and here VBY. Clear? And this is current coil. So here it is your W2 and it is your W1. Clear? We will draw the phasor diagram. Here what current will flow? IR current. And what current here? IB current. And it is your y point is common. So first of all, we have to draw the phasor diagram for this. So let us draw the phasor diagram that what value we will get. Now VRN, VYN, VBN. Clear? And what about current? Let me draw current. IR, IY, IB. So all currents are lagging by some angle phi. This angle will be phi. Clear? Now what we will do, take this IYN in the opposite direction here. VYN, it will be of negative sign because VYN positive in this direction, then it will be negative in this direction. So what will be the value of VRY? VRY will be equal to VRN minus VYN. Similarly, VBY, in my previous lecture, we have discussed this concept, VBN minus VYN. Okay, so now what we have to do, look here, these two, the phase difference between these two was 120 degree. Now this VYN, it is in the midpoint, so these two angles will be what, 60 and 60. This angle will be 60 and this angle also will be 60 degree. Clear? Be precise about this. Now we have to find the resultant of this VRN and VYN. Let me draw with different color so we can clearly get the idea. So what will be VRY? This will be your VRY. VRN minus VYN. So this is also in the midpoint, so this angle will be 30 degree. Clear? Okay. Now again in this direction, VBN minus VYN, we have to find the resultant of this. So it will be like this, VBY. So again this angle will be 30 and this angle will be 30. So now look here clearly what we are doing. Okay, now come back to the circuit. First of all, this W1 is reading current IR and voltage VRY, and obviously the phase angle between these two, so VI cos phi. So W1 will read VRY IR cos. What is angle between VRY and IR? Here look, this VRY to VRN, this angle is 30 degree and this angle is phi. So overall the angle between, look here, the angle between these two terms, whole, this angle will be equal to what, 30 degree plus phi. It is clear? So the angle will be cos 30 plus phi. Okay, this will be your W1. Now let us talk about W2. W2 is what it will reading, it will take VBY. So VBY, current IB. Now we have to discuss the angle difference between voltage and current. Look here, this VBY and here this current I. So this total angle is 30 degree and this small angle is phi. So this small angle will be equal to what? Only this angle. This angle will be equal to 30 degree minus phi, because this whole angle is 30 and this small angle is phi. So the difference between 30 minus phi will be this angle. Clear? So you need to learn this thing, cos 30 minus phi. So these are the readings of W1 and W2. Now we have to change and iterate all these readings and we will find the power factor and the phase angle between these two. Okay, so let me take this Vrn is Vry is what? Line voltage, so it will be replaced by VL. Similarly, V by will be replaced by VL, and this IR, IY and IB is what? In a star connection, line current and phase current will remain same. So IR, IB, IY all will be replaced by IL. So I will replace these two terms by VL and IL. So look here, what will be the final equation of W1 and W2? Then we will proceed further. Look here. So W1 will be equal to VL IL cos 30 plus 5, and W2 will be equal to what? VL IL cos 30 minus 5. Okay. Now we will find W1 plus W2. So it will be equal to VL IL cos 30 plus 5 plus VL IL cos 30 minus 5. So let me take VL IL as common, and cos 30 plus 5 plus cos 30 minus 5. So here it will be equal to VL IL 2 cos 2 2 cos 30 degree cos, basically it will be what? Cos c plus d by 2, 2 cos c plus d by 2 cos c minus d by 2. So this will be the formula, cos c plus cos d. So it will be equal to 2 cos c plus d by 2 cos c minus d by 2. Let me write the formula. Cos c plus cos d. So it will be equal to 2 cos c plus d by 2 cos c minus d by 2. It will be your cos c plus cos d. So cos 30 will be equal to root 3 by 2, and this cos phi. So 2 and 2 will get cancelled out. So W1 plus W2 will be equal to what? VL IL 2 into root 3 by 2 cos phi. So 2 and 2 will get cancelled out. So overall you will get root 3 VL IL cos phi. So this is the expression of power for three-phase circuit. Okay, this is the expression for power only. Now let me take W2 minus W1. So it will be equal to VLIL will get common, and inside cos 30 minus phi minus cos 30 plus phi. So cos C minus cos D. So it will get convert VLIL sin phi. W2 minus W1. Yeah. So basically when you will multiply with root 3, you will get the three-phase reactive power. Okay. Now let us take the ratio of these two readings. W2 minus W1 upon W2 plus W1. So VLIL sin phi upon root 3 VLIL cos phi. VLIL will get cancelled out. Let me multiply root 3 in that side. So what I will get 10 phi is equal to root 3 W2 minus W1 upon W2 plus W1. So what will the value of phi? So phi will be equal to tan inverse root 3 W2 minus W1 upon W2 plus W1. So it will be the expression for phase angle. And we can calculate, if phi is obtained, then we can calculate the power factor cos phi. So it will be equal to cos of tan inverse root 3 W2 minus W1 upon W2 plus W1. Clear? So it will be the concept of power factor and three phase power. Now, what will be the effect of phase angle phi or power factor on the readings? So let us draw a table, so we will get the final result. Here it will be phi, and these will be 0 degree, 60 degree, more than 60, and here it will be 90 degree, fourth column. So here what we will draw, cos phi, then W2, then W1, and we will final conclusion. Yeah. So what will the value of cos phi at 0 degree? Power factor will be 1. Okay. And what will the W2? Here look, what is W2 and W1? What are W2 and W1? Here the values of W2 and W1 are. Here the values of W2 and W1. So what will the value of W2 when phi will be 0? Cos 30 will be equal to 1 by 2. Phi will be 0. So cos 30 will be equal to 1 by 2. So it will be equal to VL IL by 2. What will the value of W1? Again here phi will be 0. So cos 30 is 1 by 2. So VL IL by 2. So here what you can write? You can write that at 0 degree, both wattmeter will read same value. Okay, both wattmeter will read same value. It means W1 will be equal to W2. Now next, when phi is your 60 degree, now what will the power factor? 0.5. Now W2, put here 60 degree, so it will be equal to cos minus 30, and in cos minus does not consist, so it will be VLIL by 2. Okay, VLIL by 2. Clear? Now put here 60 degree, then 30 plus 60, it will become 90 degree, so cos 90 will be 0, so this W1 will be equal to 0. So conclusion is what? W1 is equal to 0, so total power is equal to W2 only. Okay. Now next is when it is more than 60 degree. Again, let us take some example like 75, 80, something like that, more than 60 degree. Then again it will provide you a positive value, and what will the power factor? It will be less than 0.5, because as the value will increase, the cos value will reduce, and at 90 degree value will be 0. Okay. So what will the value of W2? Here when phi will be like 75 degree, again it will come out to be cos 45 degree, sorry, 35 degree. So here it will be, suppose phi is 75 degree. For example, let us take phi is 75 degree. So what it will be? So it will be, let me take here 75 degree. Okay, so here you will get 75 minus 30 degree, 30 minus 75, so minus 45 degree. Minus does not exist in cos, so it will become VL IL by root 2. Cos 45 is equal to what? Root 2, 1 by root 2. So it will be VL IL by root 2. It means some positive value. Now come here, cos 30 plus 75. So it will become cos 105. We are not having the value of cos 105. So let me calculate what is the value of cos 105 degree. Cos 105. So it will be negative value. So you will get minus 0.25 multiplied by VLIL. So it means some negative value. And at 90, 30 minus 90, it will be minus 60. So value will be what? Positive value. And what will the value? Cos 60 is equal to what? 1 by 2. So VLIL by 2. VLIL by 2. And here cos 120 degree, cos 30 plus 90, cos 120 degree. So value of cos 120 will be minus 0.5. So it will be minus VLIL by 2. So both value will be equal with opposite signs. So what conclusion we can write here? What conclusion we can write here? So total power will be equal to W2 minus W1. And here what is the significance? W2 is equal to minus of W1. Okay. So this is the total power will be equal to 0. When you will add these two, value will get cancelled out. So total power will be equal to 0. So this is all about the 2 wattmeter method. Okay. So you have to remember this formula, that what is the how we can apply the 2 wattmeter method for power measurement, what will be the value of power, and how to calculate the phase angle and then power factor for the load. Okay, thank you so much.